I've decided to put problems 1, 2, and 3 together because they're very similar in nature and not that difficult to solve if you're just careful with your table and then drawing a graph, which a graphing calculator will do. But with the first 3 problems, you got to be careful to choose your window appropriately and include negative t values as well as positive t values. If you use Zoom Standard on the 8384, it doesn't use negative values, and I'll explain why in the last 3 problems. So here you have problem 1, x is equal to t minus 1, y is equal to t cubed. You actually again could do this by hand, generate that table, and then plot the points. And the thing you want to be careful of is showing orientation, which is really the direction of the curve. This is supposed to illustrate motion. So you see the arrows on there illustrating when time is -2, you're down there at -3, -8, and then as you travel upwards in time to -1, the graph then travels upwards. So the orientation is very important to show for future work when you're dealing with vectors. When eliminating the parameter, the best thing to do is look for the easy way out. So if you see x is equal to t minus 1, you can solve that for t pretty easily just by adding 1 to both sides of the equation. You find out that t is equivalent to x plus 1, hop into the second equation, y is equal to t cubed, and replace t with x plus 1, and you get a rectangular equation without the parameter of y is equal to x plus 1 to the third. Problem 2. I reversed the t cubed and the t minus 1 to show you that you can develop the inverse function just by switching the x and y coordinates, which is what an inverse is all about. So x is equal to t cubed, y is equal to t minus 1. The table reverses when you eliminate the parameter. Rather than solving that for x, you're going to solve it for y and get t is equal to y plus 1. Replacing it, you get x is equal to y plus 1 cubed. Or again, if you wanted that to be in f of x form, you would simply just replace it in a different fashion to get y is equal to the cube root of x minus 1, which is the inverse function of problem 1. And again, make sure you show your orientation in the graph. And problem 3, a little bit more awkward one. X is equal to e to the t, y is equal to t squared. So when you fill in your table, you have to use some approximation of the decimals. Again, your calculator will do this quite nicely. And eliminating the parameter, well, the inverse of e to the t is the natural log. So you take the natural log of x is equal to natural log of e to the t. Solve that, you get t is equal to natural log of x, since the natural log of e to the t kind of reverse one another. And you get y is equal to t squared, or y is equal to the ln of x quantity squared. And again, showing your orientation on the graph.